Hello everyone, welcome to CoffeeJUG. Today I'm happy to introduce you Oleh Melnyk, who is always prepared to talk about new JDK version. First of all, I want to thank you, our Ukrainian armed forces, and remember to support them. And remember that even a small coffee in the morning could help our defenders eliminate Russians on our land. We already organized more than 51 unique events with more than 700 unique participants in CoffeeJUG, and I want to say thank you to our organizers team. It's Igor, Uliana, Olesa, and Oleh. We have today community partner JetBrains. And join us in our social medias, Facebook, Twitter, and Telegram. And Oleh, the stage is yours.
Thank you. Okay, let's get started. So I'm pretty glad to be today in CoffeeJUG event to share some insights from latest JDK release, and hope you have a great day. You fixed all bugs and resolved all issue, so we can focus on that presentation and learn something new. So let's go and see what's inside. Before diving into details of the latest JDK, let me introduce myself. So my name is Oleh. I am a software engineer at Jappware with more than 6 years of experience. And I'm Java enthusiast. I always trying to learn something new from Java ecosystem and of course share it with everyone to discuss together and to learn something together as well. And if you also like coffee like me, we already have something in common. Also, please, let's connect in the social media so we can contact and be friends even after that presentation. And of course, it's worth to remind to donate and support Armed Forces of Ukraine, because only together we are strong. And please support everyone who participate in that defending against brutal Russian occupation, brutal Russia invasion that started almost 3 years ago in that 10 years war. And a big thanks that we have an opportunity today to have this event. And I would like to share the following QR code when you can follow and find the website of our local Lviv volunteer organization with active fundraising. So please do not hesitate and support even with a small donation, since every bit matters. Only together we can make a difference. Let's start from our plan for today's presentation. And first of all, we'll review the current state of JDK in entire timeline. And since Java has a long history, we need to understand where we are. And also, we'll review feature by feature in scope of logical groups. Like, first of all, we'll review language features. Then we will explore some common core library API enhancements, and check what inside tooling and performance improvements group. And of course, since each JDK release improving itself, removing some outdated stuff, so we'll check out some deprecations and removals in that release. And for sure, would be nice to move, forward and maybe predict what might expect us in the future releases and what might be the next steps for JDK. I would also like to answer your questions. Hopefully we'll have some, and we're glad to answer them. All right, so as I mentioned, first of all, timeline, where we are. So we are here. It's JDK 23, and it's released, I would probably a week ago, if I'm not wrong. Yeah, and this is not a long-term support release, but anyway, it's stable enough. It's ready to use even for production, since long-term support only relevant if you're using distribution of JDK from commercial distributions, so you have a license with a support. Otherwise, JDK 21, even if it's LTS, but from the free distributions, almost the same as JDK 23. So don't think that it's some beta version of JDK or something unstable. Feel free to use, update, and let's move with progress. And the next LTS release should be JDK 25, and its release scheduled to be released in September 2025. Yeah, and yeah, we'll be pretty excited because new features should come here. Okay, JDK 23. So it includes 12 JAPs, and 9 of them are in preview or in so-called incubator state, which means they are not fully finalized. They might be experimental. Something might change in API, so we cannot fully rely on its design or its API. And the main point is to collect some feedback from community and improve those features. But there are 3 finalized and delivered features, and they are ready to use and they are stable enough. And there is one not included in that list because it was dropped before JDK 23 officially released, but let's jump on that a bit later. Okay, we are on the first stage, language features, and first JAP is primitive types in patterns, instance of, and switch. It's a preview state of that feature. It's not fully finalized, and it's a first preview. Let's explore what's inside. But before understand the core concept of that feature, we should understand the problem, the limitation before that motivates JDK engineers to implement that feature. So if you remember, instance of is limited to be used only with reference types. You can check a type of regular primitive like int, like I don't know, byte, double, and any other type. You can only use instance of keyword with reference types to check its object, its class, which leads to need to do manual casting of primitives, for instance, from int to byte, from int to double, and etc., which might cause some data loss and I don't know, unsafe casting, etc., and need to do all of that manually. It's a bit disturbing. And from a switch expression and switch statements world, they're limited to use only some specific types that they could handle. For instance, till now, you can't use long, float, double, or int on Boolean in a switch expression or statements supported except the reference types. I believe it's integers and enums, right? And strings and characters, yeah, if I'm not wrong. So let's move forward. How switch over primitives looked before. Let's explore the following method to parse and handle status code. And here we have a regular switch expression where we have a different cases for status code, and all the rest, not specific status code handling, come to default branch. But we can rewrite it in a different way to use primitives as well. So after that JAP, we can eliminate default branch in our switch expression and directly type integer in that case branch, and all unknown status codes will come here. And it's more safer because default branch, it's kind of black hole that can accept everything that is not defined in the case. But here, if we put something different like long, for instance, it won't be handled by int, and compiler will tell us to improve our implementation. But result is the same here if you want to use a case branch with int. So it can match that our error code, its type of int, even if it's primitive. The next example shows improved version of switch expression over primitive types. And here we use a guarded patterns, which means we can specify some range of values acceptable by the specific case branch. as here we can not only accept general integer code, error code, but can also provide some range-specific conditions for our status codes. So we can check that our status code is client error or server error, and it's much more readable and easy to maintain than having it in different if statements. Pretty nice and work by the same way as guarded patterns with reference types. Remember I mentioned that there is possible errors with unsafe casting from one primitive type to another. So here you can see implementation of not ideal implementation. I believe there are bugs here and it's error prone and not robust to reuse. So here process sensor data accepts some double value and we're checking could that value fit inside integer or maybe float or maybe some byte value, and it looks a bit hard to understand and hard to rely on that code. And to be honest, what's going on in that function? Yeah, I don't know. Let's improve it better than understanding what's going on here. So we can improve the previous implementation by utilizing pattern matching for instance of, including safe cast. Here we re-implemented process sensor data method to use instance of. And we can use instance of not only for reference type, because that was a limitation before, but with the primitives as well. And it's pretty handy in that case because it performs a safe cast. So here in the first if statement, it's automatically initialize int value with a double value that was in the method. So it doing under the hood checking could double value of this sensor value fit inside integer. If yes, it will go inside that if statement. And by the same way, we can check whether the following double value can fit inside the float value or fit inside byte value. So no need to do manual casting and I know some specific checking for ranges of that value. Also, we can rewrite that function to use pretty nice switch expression, so it's even more readable, even easier to maintain and easier to extend. Pretty nice. Let's move forward. That's good code, yeah. And code reviewers will thank you if you'll use the following approach in the future. But you need to keep in mind label dominance. What does it mean? In the following example, we put long switch case as the first branch in our switch expression, and byte and integer are below. But compiler will throw error for us because byte and int label is dominated by a case label long. So we need to keep in mind and put more specific case branches on the top level and more general one below on the bottom level. Otherwise, this more general switch case will dominate. Also, in scope of that job, there is enhanced support for primitive types in record patterns. So if you remember what is a record pattern, it's kind of the constructor or the construction of record state. Since record is a nominal tuple, it has everything accessible publicly and it's immutable. So we can use instance of to match the current record structure and deconstruct it. We can directly access its own components, like here. We're matching that our transaction instance of a transaction record with the following components, and we can use ID, amount, and type. But till now, record patterns were limited to use a specific primitive type. So you can't use a record pattern and specify int amount or float amount. You should specify exact the same type as defined in the record. But what if our amount can fit into byte or into int or any other primitive types? Then we can use improved record patterns. And here how we can have different branches to handle transactions with a byte amount, values that can fit into byte amount, or values that can fit into int amount. And there are different patterns, but anyway, its structure is the same. Yeah. So it's also might be pretty useful to use in some use cases. Yeah. That's all from primitive usage in instance of and switch expressions. Let's move to the next JAP. It's a flexible constructor bodies. It's a second preview of that feature, and previously it called differently, like statements before super, and this, if I'm not wrong. And what is the main goal of that JAP? Is actually to improve this inflexibility of Java constructors, because they require explicit constructor invocation like super or this before even we want to put before any other statements. So these invocations should be the very first in our constructor. It's a bit inflexible, and it might be not that easy to maintain in some complex scenarios. So let's see how we can improve that limitations. So before flexible constructor bodies, we can write our Java code like the following. Let's imagine we have a message class like that. Pretty simple, with just one field called content, it's string. And we have a subtype called encrypted message. So before passing message to a parent constructor, we want to encrypt it. So to do so, we can't declare the local variable and only then pass to the constructor, because it's not allowed in current JDK, like before 23. And to do so, we should implement either alternative constructor or, I don't know, some utility helper method to do so. Like here, we have a static method to encrypt and then use it in a super constructor. But what if we have many of these validations and we have many helper functions, and it's hard to maintain our code distributed between different methods, and it's pretty hard to maintain. Let's improve that scenario. So how it might be improved here? With help of that JAP, we move our logic out of utility static method and put directly to the constructor here, and only then passing the encrypted content to the parent constructor. It's allowed because we are not manipulating with state of object under creation, so we are not accessing any this reference, any reference of currently object under creating, so not in either the properties or methods. So we're just creating some local variables, do some validations of input, and that's it. And only then we pass that value to the parent constructor. It's flexible because everything in the same place. It's easy to read it and easy to maintain and see what's going on in our constructor, and no need to do and implement multiple constructors to do almost similar work. But there might be also another issue with the limitations that we can't put statements before super and this. So here, let's review a bit different example. We have also simple class person that on creation call introduce method. And we have employee. Employee is a subtype of person, and here we initializing department only after we calling superclass. But also in employee subtype, we overriding introduced method and we printing some department. But you can see that, okay, if I call introduce in a superclass and override that method, that means that null department will be printed because I initialize it after introduced has been completed. Let's fix it. How we can fix it? Easily by moving our internal state initialization before super class constructor. So we put this department before super, and it's fixed. We make sure that our department in 100% will be initialized. It's not a default value and not null reference. well introduced will be cool. So that's the only change that was introduced in the current JEP. So flexible constructor bodies offer us direct validation and preparation directly in the constructor. Also, it helps us to initialize fields early before they can even be used, and it improves readability and maintainability of our code. The next JEP is a module import declaration. It's also new and in a preview state. Let's see what's inside. Here you can see the regular Java application, pretty simple. It has some imports from Java util package and doing some stream processing of records, so nothing special. And in some cases, in large application, those import lists might be pretty large. And for beginners, it's also hard to remember old packages that they can use. Maybe they're not using some cool modern IDE and need to write it manually, so easy to forget it. And better to replace it with something more compact. So let's remove all of these imports and replace with cool and shorthand module declaration. So here, instead of defining import of each package from Java base, we completely can import entire module Java base. So and use everything that exported by that module. It eliminates writing all of these package imports, and we can have our Java file more compact and shorter. But what to do in the situations when we have, for instance, multiple imports? Like here, we import module Java base and import module Java SQL, and we want to use a date class. This date class exported in both modules, so there is a conflict. So compiler don't know which one to use in your code. And to help a bit our compiler, we need to explicitly specify, hey, please use the following date class from Java util. And that's how issue is resolved. Pretty easy, and no need to do something special. Yeah, and it's really short and compact. So that's it. That's it from that cool feature, compact feature, and compact explanation. Let's move on. Next one from the language features, it's implicitly declared classes and instance main methods. It's a third preview of that feature. So let's start from the first one to understand the original history of that feature. Here you can also see a pretty simple regular Java application. I know everyone probably implemented such application to write something in console, read from console, some console application, right? And here it's to convert temperature from different values. Okay, but for a beginner, it's really hard to understand all these object-oriented concepts. What is the static? What's the public and private modifiers? What is the arguments inside main? Why should I build a surrounding class for my main method? What all this imports package? Yeah, it's totally new stuff, and it's hard to learn everything in the beginning. I just want to write a full and powerful calculator. I don't want to learn object-oriented principles. So let's simplify it a bit for those who just want to get started with Java and learn it incrementally from the simple concepts. First of all, we can remove this public static and also arguments in the main method, because now compiler knows that even instance main method could be an entry point. So no need to have it public and static, and also no need to have these arguments. Okay, fair enough. Let's improve even more. We can even remove surrounding class declaration, and no need to have also a modifiers for functions, even more simpler, because it can generate this class for us. It's implicitly generated for the following simple single file Java applications. But if we want to use implicitly declared classes, we can't use package declarations, because no one can reference to implicitly declared class, which means we can't have a package declared here. So it should be unnamed as well. So we slightly simplified our application, but that could be even more. Most applications come with JAP in the JDK 23. So first of all, they introduce simplify I/O operations, and a new class introduced in Java I/O package called I/O. And there are a few static functions to work with the console. Also, in simple single file Java applications that use implicitly declared classes and instance main methods, they automatically use a Java base implicitly, and no need to explicitly define that we want to use all the classes from Java base. So in the end, our console application might look like that. We use new I/O methods in our application, so even shorter than system out print line, just print line and read line. And also no need to do explicit imports. Everything from Java base imported implicitly. Cool, and you can focus on your the first steps of programming in Java and in simple concepts. Nice, very simple. So the next group is API enhancement. We are done with the language improvements, and now let's review what's improved in terms of API. Here we can see class file API. It's a second preview of that feature, and the main goal is to improve bytecode manipulation. And so what is a bytecode manipulation, and what is the main purpose of that functionality? First of all is to generate code at runtime, also to implement some cross-cutting concerns for our implementation for our Java classes or methods, like I know maybe to put logging dynamically for all methods for beginning and for end of our method, or some kind of security validation for each method. So that might be there might be different use cases. Or maybe you want to have a code analysis and metrics. You want to analyze our code base, statically read all structures, analyze how many public methods are there, how many states, what state exposed, how many static variables, etc. So it might be pretty useful to build such tools. And of course, performance optimizations might be included in a bytecode manipulation, and many, many more use cases. But right now, it's pretty complex to manipulate with bytecode. And de facto, most used library is ACM, and it's pretty old library, relatively old, and it's not JDK internal library. They have their own copy of ACM and need to support it, and also different libraries should update the ACM implementations to support the latest bytecode version. And it can't be done until new JDK release, so you should wait some time when your favorite library improves the implementation of ACM. And it would be nice to have something more standardized, and to have some common API that's supported by JDK. Yeah. So the purpose of class file API is to build this standard and common API for parsing, generating, and transforming Java class files. Also, the main goal is to replace the bytecode manipulation framework like ACM, so they internal copy, and evolve. So API should evolve together with a class file format, and no need to wait until library like ACM will be updated. So you can rely on the new JDK release and use class file API, because it definitely will support all latest feature introduced in the latest release. Let me demonstrate you the really simple example of how we can manipulate with compiled class. So here you can see I read some test class bytes. So it's a compiled one. And then using abstractions and API of class file package, I reading and parsing the class model, and then trying to find all public methods in my compiled class and printing them. For instance, I want to have some metrics to determine how many public methods my services have to have some limitations, to do not expose too much or something like that. So it's just one of the many use cases, and of course it's pretty simple. The more complex use cases may be to generate new class Java class files, and also to mutate and change existing ones, but it's pretty complex, and there may be a different presentation for that only. Let's move on. From API enhancements, there is pretty cool stream improvements called stream gathers, and it's a second preview without any change with the comparison of the first one. But anyway, let's refresh what is that. So probably Stream API, it's well known for every Java engineer, and there are two main operations in Stream API. It's intermediate operations and it's terminal operations. So what is intermediate operation? It's something that in the middle of our stream pipeline processing. So it may be a map, filter, limit, and many more. There are several predefined intermediate operations, and we can continue working with other stream. And there are terminal operations. Their goal is to collect our result into some collections or into some single value, so to reduce everything that we have processed. And you can implement your own terminal operation by using pretty flexible collector interface. And it would be nice to have something similar for intermediate operations, to have such an abstraction to do so, since a collector is, even all the predefined collectors, it's just implementation of collector interface. Let's see what can we do with the custom intermediate operations. So the following job introduced the concept of stream gathers, and the goal of that newly introduced interface to implement this custom intermediate operations. Let's see how gather interface looks like. So it looks like the following, with three typed references. And here the first type is a type of input element that you want to process. The second one is a potentially mutable state of our newly intermediate operation. Why it's potentially? Because operation may be stateful or stateless, so it's optional. And also it's a type of output element, since we can transform our element in the stream pipeline. And the four main parts of gather interface, let's understand each of them. First component is initializer, and it's responsible to create a new potentially mutable state. And also this one is optional. It's not a requirement to have a state in our intermediate operation. And it's nothing more than just a fancy alias for a supplier interface. So we just return you just need to specify a factory how we want to build our state. Next part is integrator. Actually, it's the main part of gather interface, and its responsibility is to define how we want to process elements and how we want to then push them to the downstream and maybe transform even them in that operation. Combiner method is responsible to provide information how you want to merge partial result from two different threads if you want to use parallel stream processing. And finisher is also optional part of gather interface, and it's responsible to provide some finalizing operation after processing all elements in our stream pipeline. So when there are no elements, we call finisher method. Okay, let's move forward. Even though gather interface goal is to provide custom intermediate operations that might be built by engineers by their own, anyway, JDK provided several built-in gathers, so new intermediate operations using a new API. First one is a fold operation. It's similar to reduce collector, but it's an intermediate operation, and we can continue processing our elements. Also, there is a map concurrent, And it's pretty straightforward. It's to map our elements in parallel threads. Also, there is a scan. It's for accumulative processing of our elements, and window fixed and window sliding. They are pretty similar, and the goal is to group our element into fixed lists. And the only difference of how these fixed groups are sliding in our elements. So window fixed group elements, for instance, by 3 and sliding to the size of that window, and window sliding just sliding our group one by one. Here how we can use custom intermediate operation, and we can chain as many as we want in other operations. So that's how window fixed usage looks like. But also you can implement many custom intermediate operations. Let's see, for instance, how we can implement distinct by gather. So to do so, we define a static method called distinct by that return our new gather interface, and it has some input type like t, and the return type as the same, and we define the state type. It's a set because we want to use a set to understand should we move our element next to downstream or not, because maybe it was processed before. We want to have only distinct elements by some specific property of the object. To implement new gather, we need to implement, first of all, initializer. Here we just provide a method reference to hash set. So we want to create an empty state with the following method. Also, let's implement how we want to process. So we implement an integrator, the main part of our gather interface. And here it's also pretty straightforward. We applying some key extractor function because we want to operate with specific property of our object, and then simply check whether we already processed object with a similar key or not. If it's something new based on the property of that key, then we push element to the downstream. If not, we do nothing, just return true. True indicates that we want to process more elements. If you return false, we don't want to process any further elements. And combiner and finisher are optional here, and do not implement them. That's how we can easily use new intermediate operation in our stream pipeline. That's it. And there are even I already saw there are libraries with more than 10 or 20 custom intermediate operations that you can use. So someone already implemented some useful intermediate operation for us. So that's why it's pretty flexible and useful in Stream API. The next one from API improvements is structured concurrency, and it's also a third preview. Firstly, it was introduced in JDK 21, and let's see what the main goal of that JAP. Before understanding the concept of structured concurrency, let's understand the problem of concurrency. So writing concurrent programs, it's pretty hard. First of all, because of maintainability issues, and it's hard to track state of all child threads and how to manage them, especially when we want to rely on the common result of all of these subtasks. So it's not that easy how it looks from the first perspective. Let's see how unstructured way looks like. Here we use executor service to create child threads. For instance, we want to fetch user information and order information, and then combine result of both subtasks. But what if, what if one of these threads failed and throw exceptions that I don't want to fetch order if fetching user completed unsuccessfully, or if parent thread interrupted that I don't want to have these child threads being running, I want to cancel them automatically. But I should manage all of that by my own. And instead of focusing on business logic, I should focus on how to manage and manipulate these thread states and results. Not that easy to do. How structured way should look like? So JAP introduced kind of that concept of structured concurrency. So if you have, in general, our task structure, then we should have our code structured as well. So they introduce concept of structured task scope, the new class, and specific policy shutdown on failure. So let's rewrite the previous implementation of fetching order and user details in a bit different way. Here we're defining a structured task scope, and all our subtasks will be performed in scope of that structured task surrounding scope. Yeah. Then we're starting our subtasks, and they are lifetime bounded in that scope, and also we can wait until all of these tasks are finished. And also, if any exception occurred in the subtask, we can interrupt entire scope, because here all our subtasks anyway part of common unit. So we want to work with our subtask as a part of some common logic, and not as a parallel threads that are unrelated. And to do so, we can just combine results of user fetching and order fetching like that, and no need to manual tracking of state. No need to do manual tracking of subtask status, how to handle errors in the subtask, and any other problems. So here it's automatic cancellations of entire scope if something happened in a subtask. Also, it simplifies error handling if parent thread interrupted, or if sub thread interrupted as well. Also, it's more efficient resource management and observability, because there will be no thread leaks, and there will be no ongoing threads when parent task is failed and child task is still in progress, or when you want to check thread dump, and in the previous example it's just unrelated threads, but here all threads created in scope of structured task scope included in a thread dump, and you can see this relationship between parent and child task. There is also a second policy called shutdown on success. And it's a bit different from the previous one, because if in previous one, shutdown on failure, we cancel all our subtasks if at least one is failed, here we can run multiple tasks and wait until at least one successfully finished and cancel all the rest. So for instance, we might have some fetching data from a specific URL, and we may have a list of these URLs, and I want to process first successful result of that fetching. So I waiting until any subtask finished. I can define some specific deadline to do not wait for infinite time, but have some final time for that, and just return result. Here result will contain fetching data from the first successful subtask, and all tasks will be canceled. So also nothing to manage by our own. We are focusing on a business case. But also we can implement even custom shutdown policy and how you want to handle our subtask. It's easy to do by just extending structured task scope, and that's it. Here we modifying our structured task scope. It's pretty similar to shutdown on success, but we want to keep some specific number of successfully completed tasks and results. And to do so, we only need to override handle complete method and define how you want to handle state of our subtask and what you want to do with the successful result. Okay, that's it from structured concurrency. And next one from API enhancement, probably the last one from that group, is scoped values. It's a third preview. Only one change, not significant change included here, but let's also understand and refresh in our mind what is that scoped values. So the main goal of scoped values is to provide efficient data sharing of immutable data within and across threads. And it kind of alternative to thread local variables, because of many key points, and they're really better to use in some specific scenarios. Let's define how we can use a scoped value. Imagine we have some web framework, and this web framework processing some user request, and we want to use scoped value here and use its benefits to process a request. First of all, let's define a scoped value. Usually it's a static final variable in our class, and that's how we can build new instance. But of course, it's just wrapper, it's just a scoped value instance. It's not containing any value so far. Let's move on. We have our handle request method, and here we handle request initializing some state, some request context, and here the main part, how we binding value to our scoped value instance. So we simply calling run where we providing which scoped value we want to initialize. Here if we bind value for context with the current request context, and then we have a lambda to be executed that can access that scoped value. So our scoped value lifetime only restricted and limited to that specific scope inside that lambda. So only application handle method can use context value binded here. And that's how application handle method can access context. So here, first of all, we need to check that whether a value bound or not. If not, we should throw exception, because if it's not bound, it's anyway can be accessed. And then easily use a get method to access value. So there is no method to set value or something similar, because it's immutable. Our scoped value immutable. And our applications that handle request can simply access context by using a static variable, and this context contains some user-specific request. So first of all, it's immutable state shared between different application parts or different threads. Also, no need to explicitly pass some argument in our function, so we can access it by using a static final variable, and we can make sure that nothing can change that value, some other application part, since it's immutable. So let's highlight the main benefits of scoped values. First of all, it's preferred to thread local for virtual threads, because we can start millions of virtual threads, and thread local create a copy for each thread that created. So it's not efficient in terms of resources. Better to use scoped values that are more lightweight. Also, it's immutable data sharing, since thread locals are mutable, and scoped values are immutable, and it's more reliable and more efficient to use as well. Also, it has a smaller footprint and complexity in terms of memory usage, and of course, it has a bounded lifetime. In comparison with thread local, it's not exist in the thread until thread running. It exists in that specific scope of execution, so in that lambda, if you remember. Let's see the more examples of scoped values. So we can bind even multiple scoped values and then run specific instructions in our run method, or scoped values can be also reused and inherited in the child threads, but only with combination of structured task scope. All subtasks in the structured task scope can access the same scoped value that's binded in the upper context, like here. My user task can access context value because it was binded before all of this execution even started. So cool that we can reuse it, and it's not copied, it's using the same instance. In addition to a run operation, we might have also callable action for our scoped execution, scope value execution, because maybe our execution should return some result, but not just consume and do something. So it's not only run operation, but also callable operation. So that's how we can use a callable operation. It's pretty simple, similar to runware. We just, instead of providing runnable, we're providing a callable operation. But here it's not even just a supplier. It's a new functional interface called callable operation. And the only difference from a supplier is that it can throw checked exception that may be propagated on a parent function, parent scope. That's it from scoped values. And here we have vector API. Our beloved vector API is an 8 incubator. It's still in that incubating state. Why? Because it's still waiting for a Project Valhalla to have a best performance of vector computation. Because if you remember, Project Valhalla goal is to unify primitives and reference type together and then maybe used in generics, and they are under the same hierarchy, kind of. So that's why it's still in that preview phase of incubator. And just to highlight why it's designed and built, vector API goal is to have predictable vector computations, compiled vector computations on any processor, and easy to use, and do not rely on some automatic vectorization for some specific processors. So to provide a pretty flexible and easy to use API for many vector computations. Let's jump into JVM enhancements. Here we have improvement of ZGC, and for that garbage collector generational mode turned on by default. So what is a ZGC? It's a alternative to default garbage collector, and it's scalable, low latency garbage collector, preferable to use in a large application with large heap, where small pauses of garbage collector are expected, because need to have low latency. And how we can enable it for our Java application? Just by using this JVM argument to use ZGC, and we can also enable generational mode for that garbage collector. But since that JAP generational option is deprecated because it's a default mode, and it's not reliable in the future releases and might be completely removed, as well as turned off generational mode. So it can be also removed in future releases, and this option is deprecated. So if you want to use that garbage collector, just use the following option. Yeah, so generational mode should improve how garbage collector collecting diet objects and application performance in general. That's why default mode is preferable in all use cases. The last one from JAPs are part of tooling improvements, and it's Markdown documentation comments. Documentation. Whoever write documentation, I know every one of us is documentation. If I'm implementing something, just ask me. So probably right now it's each developer had. But maybe team lead or manager may ask you to build some documentation, and traditional Java doc comments require from us to understand HTML and to know custom Java doc tags, and that might be a bit verbose and hard to understand and maintain. And modern engineers are more happy with Markdown. It's a pretty popular markup language and widely used and understood for everyone and among developers especially. So if even someone asks you, hey, it would be nice to write a documentation for that perfect piece of code, you can do it better. Instead of writing documentation in that way, using HTML documentation, here you can see a pretty complex documentation for simple implementation of calculate cycle area, but it could be written in a better way, in more readable way, and without understanding all of these custom tags or HTML tags. So let's rewrite it with a cool and modern markup, markdown markup language. And that's how it might look like. So it's much more easier to define a table, to define some paragraphs, and code snippets, etc. And it's understandable by most of the developers and widely used. So Markdown documentation looks pretty nice, pretty clear, and easy to read. And to use a Markdown documentation, you need to put three slashes in the beginning of a comment. And then it will be understandable for compilator to convert it to use Markdown related syntax here. So cool, it's a finalized feature, it's ready to use, and you can write your new documentation for your new functionality by using this approach. Of course, if you updated your JDK to the latest version. From the world of removals and deprecations, we have only one. It's to deprecate memory access method in Sun misc unsafe package for removal. So previously it just were deprecated, but now it's deprecated for removal. And actually, it's not a good way to use method and that API, because it's unsafe, it's unpredictable, and mostly it's used to have some extra improvements of performance in many libraries, in some implementations. And there are some alternatives, modern alternatives, and better API, like Project Panama. It's foreign memory and functions API, and also war handle API introduced in JDK 9, I believe. So there are new API, and you should use this one, because later it won't just throw warnings when you use this unsafe API, but can throw exceptions in future releases or completely removed from a usage. All right, remember when I show what included in 12 Japs, I added extra box for dropped Jap, and it's a string template. That's a cool feature that was widely explored by many engineers in JDK 21 and 22. But here they decided to drop it and re-implement, redesign in a different way, because they collected many feedback from Java community, and not everyone was happy with that implementation. I'll just simply show how string templates look like in the previous releases. So it's kind of similar to string interpolation, already available for many programming languages like that. You can interpolate value by using slash and then curly braces, but to make it a template, need to put a str processor before a string literal. And str is nothing more than interpolation function. But in general, string templates planned and designed to be more powerful than just regular interpolation, because interpolation might include possible SQL injection errors and any other other issues with transforming to string from user input. And they want to build kind of custom processors to transform string to different concepts like JSONs, or I don't know, XML or any other object that may be transformed from a string. So I believe it will come back in the future, just in a different shape, in a different representation. And that's good, because that JDK engineers want to deliver best API for us engineers, not something like regular interpolation, that want to build something useful and flexible at the same time. And it's easy to understand, and it's fit to the entire API of string manipulations. To have more details why they are removed, I recommend the following video from official Java YouTube channel. So to understand all the preconditions and what was the initial idea of string templates and why they are removed. Also, I would recommend to watch this Java launch stream. So it's extended version of what's inside the latest release, more detailed explanation of some features or some concepts and projects. So also highly recommend. You can follow also by this QR code. Additionally, GraalVM for JDK 23 has some cool features. Especially its GraalVM just-in-time compiler now included, among others, just-in-time available as a part of the Oracle JDK. But it's still experimental feature, and to enable it, you can use the following VM arguments. So you can start your application by using GraalVM Graal just-in-time compiler. Pretty good, but you should understand that performance improvements and optimization depends on your use case and on your workload. All right, let's have some step ahead and predict what might be in Java 24. When Java 24 released? Need to wait some time since it's just JDK 23 released, but we already want to talk about next JDK. So nothing special so far. And right now, only one job included, and is to prepare this, to restrict the use of Java native interface, to use also new API instead of this legacy one. But I have some predictions based on my investigation in the internet. So what might be included in JDK 24? Potentially, there might be finalized stream gathers. Also, class file API will be finalized. There might be a new feature in the preview, like derived record creation. It's a similar to Viz annotation from Lombok. Yes, sorry, I know that Lombok is bad, but I had experience with that. So you can create a new instance of a record by just mutating single field or multiple fields. Also, I believe scoped values will also have a next preview stage in that JDK, and maybe it's just speculations. I don't know. Would be nice to finally have in preview one part of the entire Valhalla project. It's like a value classes and objects. Who knows? Maybe it will be included. I don't know. Let's hope so. That's it. Thank you all, and let's keep up to date. Let's focus on the improvement of our ecosystem of Java, and do not stay on the old version. Thank you for listening and watching me. Here you can find the slides for that presentation, and let's connect and be friends in the social media. And of course, we're glad to answer your questions from my chat. So, Slava Ukraini and Heroям Slava. And don't forget to support our armed forces of Ukraine. Thank you. Okay, I see there are some questions. We know that release from 7 to really load several years. Now we receive new things in Java much quicker, but projects essentially grows not so fast. How often you switch from to the new Java? That's a good question. To be honest, I'm trying to switch to new version as fast as possible. For sure, I'm waiting for the stable builds of distributions that we are using, because there are many JDKs, and you can wait for some specific JDK from Eclipse, for OpenJDK, or any other. But if there are no implication in terms of frameworks or libraries, I would suggest to migrate and it should not affect your application that much if you're not jumping with such a huge leap, like from I know 7 to 8, because it's a big period, it's multiple years. And here that's why they moved to a shorter release cycle, because it's easier for engineers to migrate their applications and to keep on track with the latest change. So yeah, I changed in my current project. I already on JDK 22, and I expect to migrate to the next one in a few weeks. Maybe we'll just observe libraries and that we depend on, and let's see. So yeah, the problem of migrating from a bigger projects, because they have a dependency of old libraries, and some API removed, some API deprecated, something might not work perfectly because third-party libraries are not part of JDK, so they cannot in 100% guarantee that everything will be fine with external library, right? So it depends on the project structure. Do we have more questions? Let me open it. Asking this as in live, we use new feature not so quickly. And do you use not LTS version in production? Did you have any issues with quick switch to the new versions? We are using non-LTS version because, as I mentioned, we don't have license. So if you don't have license, you don't have commercial support, and LTS JDK and non-LTS JDK almost the same for your use case. And there are some thoughts that half-year JDK releases are not stable and are not production ready, but that's not true. They just don't have a commercial support from vendors that offers these licenses and support, long-term support. And yeah, we are using JDK 22 right now in production, and everything runs smoothly. Do you have any issues with quick switch to the new version? To be honest, can't recall any issues from past two migrations, either 21 or 22. Yeah, that was pretty smoothly. I remember issues from migrating to 11 to 17 because there are some breaking change, and also a new Spring Boot version as a baseline has Java 17. So if you have this big leap and much difference between versions, yeah, there might be definitely issues. Any more questions here? In your opinion, what would be a cool or useful feature to include in the next version of Java? That's a philosophical question, and as per my predictions for future releases, would be really cool to have structured concurrency and scoped values to be finalized in the future versions. Especially, I would vote for structured concurrency because it's really easy to write some concurrent applications, concurrent calls, and combine them together. There are many use cases to use it, and I would say that may be pretty useful, not just a fancy feature to use, but it has some good benefits in terms of implementation. Also, I know this Valhalla project, entire long-term project, might be also pretty nice to see, at least in JDK 25. I'm not sure that in 24, and it might slightly improve performance of Java applications, memory footprint, because all these boxed primitive types will be more efficient to use. And in general, they're trying to improve this object hierarchy and how it's designed. And I also saw some insights about nullability and null markers similar to Kotlin. So even more improved null pointer exception handling might come in future releases. So probably this one. Yeah, and maybe extensions of pattern matching. It's also cool feature how you design work with your data classes. Yeah, so I would say these several features that I would like to have in the future releases. Okay, do we have? I missed that. Why Lombok is bad. First of all, Lombok is bad. Or do you mean bad if you're already on a Java version with records? I can't say it's completely bad since I also using that in my project. It just like it's not compile some extra code for you. It's not build some extra code. It change your existing bytecode. It manipulates with bytecode, and in some scenarios it may be not that good approach. Like it's not safe because it's touching your code. And would be nice to have a similar features from Lombok, like we already have record classes and no need to put many annotations on your class. So it just in a Java community, I widely saw that Lombok usage is kind of bad tone, something like that. Just because it's manipulating with your bytecode, yeah. Do we have? Thank you for your question. Thank you for this fire. Thank you. Glad that I answered your question. Do we have more? Or maybe I miss some of them in the chat. Alexei? No? That's it?
Yeah, I'm here. Okay, so hello again, ladies and gentlemen. Oleh have finished his talk and answered to all related questions, and that means that we are close to the end. Kudos to Oleh for delivering such incredible and informative talk today. Hope you heard something interesting for you and you could become a better version of yourself and, of course, a better engineer. The big thank you to our community partner JetBrains for long-standing support of CoffeeJUG community. And stay up to date with the latest announcement on our social medias. And thank you for being with us this evening. Don't forget to donate to Ukrainian Armed Forces. Stay safe and see you.
Thank you.